All right, you guys, so we are going to be looking at how to find the area of some triangles by using what we know about parallelograms to help us. All right, so let's get started. So let's use what we know about parallelograms to find the area of triangles. And our goal is to use what you know about parallelograms to reason about the area of triangles. So let's start with this first exercise about composing parallelograms. So on the sheet that you were given, we're going to look at the first set of exercises, and your picture should look like mine here on the screen. So Han made a copy of triangle M, so we have triangle M here. He made a copy of that triangle and composed three different parallelograms using the original M and the copy. So we have M, and then he made a copy of it. That's the yellow triangle. And then he put those two together to form some parallelograms. So your job for question 1 is for each parallelogram that he composed, identify the base and the height, and then write the measurements on the drawing. And then once you identify the base and the height, you are going to find the area using the formula that we learned on Friday, or actually on Thursday, for parallelograms, which we know is base times height. All right, so now take 1 to 2 minutes to find the area of each one of these parallelograms. All right, so pause the video, and then when you unpause it, I'll go over the answers. All right, so hopefully you had an opportunity to go through each one of these and find the base and the height. So when I look at this first parallelogram, I notice that my base, I can make that my base, and then this would be my height. So then the base would be 1, 2, 3, 4, 5, 6. So my base would be 6, 1, 2, 3, 4, and my height would be 4. And so for this parallelogram, I know the area would be 6 times 4, which is 24. For this parallelogram, I can figure out what my base and my height is. I can make this my base, and this would be 4. And I can make this my height, and this would be 6. And then again, I'm going to do 6 times 4, which gives me 24. And then for this parallelogram, again, I can make this my base. I can make this my height. And so my base would be 6, and then my height here would be 4. And so again, I'm going to do 6 times 4, and that's going to give me 24. So each one of these had a base and a height of 6 and 4, and it gave me an area of 24. So the first question is, well, what do you notice about the bases and heights of the parallelogram? So of course we notice that the bases and the heights are the same. And why do they all have the same area even though they are all different shapes? Well, they have the same area because they have the same base and the same height. So if a shape has the same base and the same height, it's going to give you the same area. And then how are the base height measurements related to the right triangle? Well, when I actually go back and I look at the right triangle that he started with, so if we go back here, here's the right triangle that he started with. When we look at the base, and we can make this the base, and this the height, well, we can see that the base of the right triangle, of just the triangle, is 1, 2, 3, 4, 5, 6. So the base of just that triangle is 6, and the height is 1, 2, 3, 4. So the base and the height of the triangle is also 4 and 6, and the base of the parallelogram is 4 and 6. So the parallelogram and the triangle have the same base and the same height. So what if I only want to find the area of just the triangle? Can we find the area of just the triangle? And how could we do that? So when we look at that picture, we can see that, well, it takes 2 triangles to make the parallelogram. So the 2 triangles together give me an area of 24. So if I just want the area of just the triangle, well, I can take that total area of 24 and I can split it in 2, or split it in half. And so if the entire parallelogram is 24, then that means each of the triangles would have to be half of 24, which is 12. So the parallelogram has an area of 24, and the triangle has an area that's half of that, which means that the triangles have an area of 12. So a triangle is half the area of a parallelogram. So now I want you to practice a few more. So now you've got this next part on your sheet. So you have 4 triangles here. Your job in the next few minutes is to find the area of at least 2 triangles. That means you can do more than 2, but you can't do less. So you need to do 2 or more triangles in the time that you've been given. And so try to take, please give them 5 minutes. And you're trying to figure out what's the area of these triangles. So you're going to want to do what Han did. You're going to want to take each one of these triangles and form some parallelograms out of them. So make a copy of it and then figure out how you can turn and kind of move those triangles around to make a to make a parallelogram, and then find the area of the parallelogram, and then we know triangle is half of that. So take about 5 minutes and then pause the video here, and when you come back, then I'll go over it. All right, so hopefully you took some time to go over the parallelogram and kind of, see how the parallelogram is related to the triangle. So what we want to do now is we want to look and see, well, how are they related? And how can I use this triangle, if I were doing A, how can I make that into a parallelogram so that I can then find the area? Because I don't have a formula for a triangle yet. So the only ones I have a formula for is I know how to find the area of rectangles, squares, and now parallelogram. So I've got to make it into one of those shapes, and then I can find the area. And so what we saw that Han did is Han made a copy of the shape, and then when he made a copy of the shape, he could take that copy, rearrange it, make it into a parallelogram. So let's do that. Turn off. Oh, you might keep getting in my way. All right, so let's move some triangles. So we have this triangle here. And y'all be kind about my little triangle. They look a little rough, but they still work. All right, so I've got this triangle here. I'm going to make a copy. So I made a copy here. And so now let's see. If I were to turn this around, and I would turn it 180 degrees. Now I flipped it over, right? So now if I take that and I place it on top, notice, what does it make? It makes a parallelogram or a rectangle, or kind of sort of. All right, so now when I look at this, I'm going to see, well, does that give me the area that's the same as, can I use that to find the area? So if I want to find the area, I can use the same formula, base times height. Well, I see that the base is 1, 2, 3, 4, 5, 6, 7, 8, and the height is 1, 2. So if I multiply the base, which is 7, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 8. If I multiply the base, that's 8, by the height, that's 2, that means that the parallelogram would have an area that's 8 times 2, which would be 16. And that means if I just want just the triangle, I can take half of that. And that means that the triangle would have an area that's half of 16, which would be 8. So this triangle on A has an area of 8. So if I look at B, I can do the same thing with B. So with B, I got my copy here. And now what I want to do is I want to take that copy, move it around so that I can see how I can form it into a parallelogram or a rectangle. And so I flipped it here. And now when I place it on top, this is really hard to do on the screen, but if I place it on top, now I've made a parallelogram. So we can see my parallelogram here. And so this parallelogram has a base of 1, 2, 3, 4, 5, 6, 7, and it has a height of 1, 2, 3. So I'm going to do 7 times 3, which gives me 21. And that's the area of the whole parallelogram, both of the triangles together. So now that I know the whole parallelogram, if I want just the triangle, I can take 21 and I can divide it in half, or divide it by 2, which will give me 10 and a half. So that means that the triangle has an area of 10 and a half, and both triangles have the same area. So they both have an area of 10 and a half. Same thing with C. I can take C. Once again, I can spin it around and then put those pieces together. When I put those pieces together, it gives me a parallelogram. So now I'm going to look and see what's the base and the height. Well, the base is 1, 2, 3, 4, 5, and the height is 1, 2, 3, 4. So if the base is 5 and the height is 4, that means the area of the parallelogram is 20. If I want just the triangle, not the parallelogram, then I've got to take the area 21. I'm sorry, what was it? 20. Sorry, take the area 20. I got to divide it in half, divide it by 2. And that means that the triangle has an area of 10. So the parallelogram, which would be the two triangles together, each one has an area of 10. So the whole thing is an area of 20, but just the triangle by itself is just 10. And then same thing with D. You can even do it with D. D looks a little strange, a little trickier, but I can still move that triangle around, put those pieces together, and I can still form a parallelogram. And this parallelogram has a base of 1, 2, 3, 4. So a base of 4 and a height. Sorry, move it together a little more. So it has a base of 4 and a height of 1, 2, 3, 4, 5, 6. A height of 6. So a base of 4, a height of 6, which means the area of the whole parallelogram would be 24. That means the area of just the triangle would be half of that, which would be 12. And so that means each of the triangles would have an area of 12. Y'all with me? I hope so. So that means let's do a little recap. If I want to find the area of this triangle, what I can do is I can make a copy of that triangle, put those two triangles together to make a parallelogram. Then find the area of the parallelogram by doing base times height. Once I get the area of the parallelogram, then I can cut that area in half, and that will give me the area of just the triangle. So the main lesson that we want to focus on is what can we now say about the area of a triangle and that of a parallelogram if they have the same height? Well, we can say that the area of the triangle is going to be half the area of the parallelogram. So if we find the area of the parallelogram, if we cut it in half, that'll give me the area of the triangle. How might we start finding the area of any triangle in general? Well, we can find the base and the height, then multiply them like we do for a parallelogram, but then we would cut that in half because we want to just have the triangle. So we can multiply the base and the height together, but then divide it in half, and that'll give us the area of the triangle. All right, that is our lesson for today. All right, at this point, you should be getting ready to do your quick check on parallelograms. Do your very best, answer every question. I will be grading it. All right, see y'all later. Bye.